After the world's largest tunnel boring machine, Bertha, retired, the U.S. secretly began developing an even larger TBM. Hidden from international media, this project aimed to construct a revolutionary transportation structure. The project progressed underground, citizens only witnessing dust clouds and hearing loud noises. Extensive research unveiled the identity of America's mysterious giant, TBM. Just how big is this machine? In this special episode, we uncover this American secret, capable of traversing a mountain in a day, undertaking a mega project to accelerate America's national development. Seeking to expedite its national progress in construction and development, the United States, specifically the Washington State Department of Transportation, developed a 17.5-meter diameter tunnel boring machine for the Alaskan Way Viaduct Replacement Tunnel Project in Seattle, Washington. This colossal machine was assembled in Osaka, Japan, and became operational in July 2013, a perfect time to showcase America's advancements in transportation and counter the earthquake potential at the time. This $80 million machine was the world's largest earth pressure balance tunnel boring machine at the time of its production, boasting some sophisticated features. Bertha had a melody specially programmed for those working inside the machine and those monitoring the TBM. However, Bertha's journey didn't begin in 2013 as the world assumed. This vision stretched back to 2001. 12 years before Bertha's launch, on February 12th, the rural community of Nisqually, Washington, was the epicenter of a 6.8 magnitude earthquake that shook the region, now known as the Ash Wednesday earthquake. In Seattle, approximately 400 people were injured in the earthquake, and one person tragically lost their life due to a heart attack. However, the most affected was the region's infrastructure. Further inspections in the area revealed that most of the infrastructure wouldn't withstand another tremor. The city swiftly organized a program to reconstruct public infrastructure, rebuilding everything except the Alaskan Way Viaduct. While repairing the viaduct was hazardous, engineers knew it wouldn't survive another earthquake, necessitating its replacement. After years of negotiations, they decided to demolish the viaduct and reconnect the north and south extensions of State Route 99 with a $3.1 billion tunnel that would run away from the waterfront, the viaduct alignment, and the Battery Street Tunnel connecting the viaduct to the road's north end in Seattle. The tunnel would pass 60 meters beneath downtown, avoiding a forest of piles, cables, and pipes from approximately 160 buildings above. This was a massive project, and engineers needed a crucial tool, Bertha, the world's largest tunnel boring machine. After being manufactured in Japan, Bertha was disassembled for easy transportation and shipped to Seattle for reassembly. It was too large for sea transit. This gigantic machine consisted of a 0-ton cutter head, a mud pipe, a shield, a control room, and rear gears. On July 30th, 2013, commissioned engineers began working with Bertha under the watchful eyes and cameras of international media. The tunnel boring machine started digging a cement plug, aiming to emerge on the other side of downtown within 14 months. While it seemed like a normal excavation from the outside, Bertha faced some dangerous challenges beyond just rock and clay. Although the entire megatunnel construction route had been surveyed and numerous test samples drilled, the detailed geology of the construction area remained uncertain. The ground in the designated area was complex and filled with varying compositions, so the drilling process was closely monitored. Guiding Bertha was also uncertain, as it was the only one of its kind. However, the operating engineers were determined to learn and solve everything they didn't know on the job. In December, 5 months after the machine's launch, Bertha encountered a devastating breakdown that could have nearly ended the entire tunnel program. The massive tunnel boring machine hit a steel pipe and shut itself down after digging 330 meters underground. A survey engineer had accidentally left the steel pipe while measuring groundwater. 3 days after the incident, things worsened. The rubber seals around the main bearing failed, allowing sand to enter the interior, damaging vital machine parts and causing overheating. Despite all efforts on site, restarting the machine proved impossible, and 2 months later, Bertha remained stuck 36 meters underground with no way out. With field engineers unable to do anything, the manufacturer, Hitachi, concluded that the only way to repair Bertha was to dig it up and partially disassemble it. After months of messy legal proceedings, debates about the repair project's funding, and sample inspections, the repair was finally completed in December 2015, just days before Christmas. Bertha started moving again, and engineers breathed a sigh of relief, but the worst was yet to come. A year later, after another excavation round, Bertha passed through a layer of stiff clay, sand, and gravel mix, approximately 36 to 45 meters below the viaduct, causing a sinkhole to open 30 meters behind the tunnel boring machine. Bertha was shut down again for 6 weeks while engineers filled the sinkhole. When it resumed operation 3 months later, Bertha was ready to progress at a depth of 60 meters. The tunnel boring machine dug through the city for 11 months without any adverse issues, and then, after a final 15 centimeters root correction in March 2017, Bertha was ready to fulfill its purpose. On April 4th, with the media watching, the massive tunnel boring machine broke through the concrete plug in the reception pit built for it. Amidst clouds of dust, Bertha made history, but met a tragic end. After the work was done, engineers began dismantling each part of the giant tunnel boring machine into smaller pieces weighing approximately 20 tons, which could be transported by road and reused in other infrastructure projects. Although Bertha held historical significance for the United States and the world, it wasn't the only giant tunnel boring machine ever produced. The United States had another massive secret it tried to keep from the world. Following Bertha, the United States was determined to do better in tunnel construction and quickly funded a new project. However, this time the project was classified. The Chesapeake Bay Bridge Tunnel project began in Virginia in 2017, right after Bertha's completion. However, it encountered numerous obstacles. The project had a 5-year timeline, meaning it was scheduled to finish in 2022. But various delays added another 5 years to its completion. This was far longer than anyone could have imagined. After delays caused by toll disputes, the United States introduced a giant tunnel boring machine named Chessie, which started digging the tunnel in February 2023. Chessie had only dug about 230 meters when workers noticed large steel pieces on a conveyor belt emerging from the tunnel to the bay's surface. Upon further investigation, engineers discovered that these steel pieces were artifacts from a ship over 50 years old. One piece had an engraving made by W.L. Byers and Company, a Sunderland, England-based company that manufactured anchors from the 1860s to the 1950s. No one knows how the anchor was buried or which ship it belonged to. The 3.5 to 5-ton British anchor was frequently encountered, but Chessie shattered it while tunneling. Engineers shut down Chessie to investigate the delay in their work. After the investigation, they removed and replaced Chessie's parts damaged by the anchor. The grinding process caused significant damage to Chessie's cutter head. 389 out of 442 tools on the cutter head, such as discs and scrapers, had to be replaced. For over 6 months, field engineers worked to repair the damaged part and dig the tunnel for another 3 months. After the replacement, the construction team worked to get Chessie's cutter head operational again. The head was approximately 90 meters long. Although the anchor obstacle added 241 days to the project, Chessie returned to work, tunneling about 15 meters per day and reaching a total of approximately 490 meters, or 25% of the planned 1,950 meters. The giant tunnel boring machine is expected to finish its work by the end of 2027. Chessie and Bertha are remarkable machines, but they aren't the only tunnel boring machines digging the world. There are other, even more sophisticated types of tunnel boring machines. However, to understand each type, you first need to grasp how they work in general. Tunnel boring is a mechanical drilling process designed to excavate complete underground tunnels. While it sounds simple, tunnel boring is far more complex than one might think. A tunnel boring machine typically weighs over 6,000 tons and is approximately 150 meters long. Since a tunnel boring machine cannot make sharp turns due to its size, it carries out the excavation with its rotating head, also known as the cutter head, which drills a hole in the ground using a hydraulic or electric system. depending on the tunnel's characteristics. The cutter head can be made of various materials. The machine generates a thrust force that keeps the rotating head drilling. At the back of the tunnel boring machine, there's a platform, trailing gear or backup, where other work equipment like transformers and fans are located, ensuring a smooth excavation process. After excavation, the tunnel boring machine stops, and rings are installed to keep the tunnel's structure stable as the machine moves. TBMs aren't the only mega construction machines available. They constitute just a portion of the largest construction machines ever produced. Bell AZ 75710, the world's largest dump truck. The Balazi 75710 is a colossal machine valued at $7 million. This dump truck comes in different sizes, one weighing 90 tons and the other 13 tons. It can carry 450 tons and up to 500 tons when overloaded, earning it a Guinness World Record. It also holds a second Guinness World Record for being the world's largest automobile, with 645 cubic meters. Its length is 20 meters, its width is 10 meters, and its height exceeds 8 meters. When overloaded, its total weight reaches 810 tons, equivalent to 2 giant Airbus A380 passenger planes. When this dump truck needs to be moved to a work site, it's too big to be transported by road. Instead, it's disassembled and carried on 20 railway platforms, occupying an entire train. This truck has two 16-cylinder engines, each producing 2,300 horsepower, resulting in a total of 4,600 horsepower. Each engine has a capacity of approximately 78 liters, making the total capacity over 156 liters, 100 times larger than a mid-range car engine. The engine's torque is around 10,000 nanometers. In comparison, a Hilux's torque is about 500 nanometers, roughly 20 times less, allowing it to run 2 generators. These generators produce 35,000 kilowatts of electricity. If a small apartment needs about 3.5 kilowatts, this vehicle can power 1,000 apartments. The Balaza 75710 has 4 wheels, each driven by its electric motor, and each motor has a power output of 1,600 horsepower. Therefore, the Balaza is an electric vehicle as it's driven by 4 electric motors. The generators supply electricity to both axles, driving all 8 wheels. Each of the 8 tires weighs about 6 tons, and one tire costs between $50,000 and $90,000. This cost is equivalent to 2 to 4 economy-class cars. Each tire has a diameter of 4 meters and is inflated up to 7 atmospheres. If such a tire exploded, it could create a crater like the explosion of 3 hand grenades. The fuel tank holds 2,800 liters, 55 times more than a Hilux. The Big Belaz truck covers about 100,000 kilometers annually and can be used for 10 to 12 years. Throughout its lifespan, it has traveled over 1 million kilometers. Because the truck operates in dusty quarries, it has 8 air filters that need frequent replacement. Belaz was first introduced to the world in 2012. 5 manufacturers, including Balazi, produce such large machines. The truck's maximum speed is 64 kilometers per h. Its small cabin has 2 seats, an automatic transmission, 2 brake pedals, 1 gas pedal, and a cooling system. When operating, one of its engines runs at 800 revolutions per minute. Liebherr L 2350, the world's largest wheel loader. Our next gigantic machine is the world's largest front loader, the Liebherr L 2350. Manufactured by the Lerno company in Longview, Texas, this enormous loader transports gold, coal, copper ore, and other materials to larger trucks. It's heavier than a Boeing 737, about the height of a 2-story building, and can lift the weight of 40 cars above its head. The loader has a 38 cubic meter rock bucket capable of lifting 80 tons. To be more practical, 38 cubic meters is equivalent to 5 regular dump trucks you see on the road. Front loaders are relatively new compared to other excavators. Although the Lerno company has a long history of manufacturing loaders, the L2350 is their first model off the assembly line. Nearby, they have a testing ground where they put the machine through various tests. The Liebherr L2350 was designed because larger trucks needed bigger loaders. As dump trucks grew in size, engineers worked for 2 years to create a loader that could lift 50% more than the previous model. They even collaborated with Firestone to create the world's largest tires.